Hey, how's it going? So in this video we are going to be doing a very long session of reversing SmokeBot, which a lot of people will probably know. And we'll be basically just reversing by simply only using X32DBG. And the reason for that is that I know that a lot of people don't have either, but as well as that, actually, a lot of it is easier for me to go through and explain than just to use a hex-raised decompiler. I know there's loads of different people that have used hex-raised decompiler and analyzed SmokeBot and actually just analyzed SmokeBot overall, but no one's actually just taken the time to actually show people the process for a very long time. So it's going to be like a really long video. I mean, hopefully it is. You'll see in the YouTube length. But yeah, hopefully it's interesting of somewhat. Just get some Maple Story music in the background and just sit back and relax and watch me sweat about how the fact that I think it could break at any point. So yeah. This is what the panel looks like for SmokeBot. SmokeBot's been around for ages since I've been analyzing. So around 2011 days, when Black Hole Exploit Kit was around, they were still here. They've had a load of different revisions. They had a cracked version leak with a builder, a load of different, and a panel in 2017, which wasn't beneficial for them. So the majority of the versions that you find are SmokeBot 2017. So unfortunately, when I looked at a public sample that was on a Sandbox that I could download. Unfortunately, it's the 2017 version. I'm sure I could find a 2020 version, but it would involve me having to use my company's account, and I'd prefer not to do that. Anyway, so yeah, this is what it looks like. We're going to be looking at bot ID generation and what that does, and just going from like step one really. Their bin size has gone a little bit up recently, which is fine, but a little bit different. So they have a load of plugins, if you don't know Smoke, which we won't be looking at all. We'll be looking at the initials of this bot and then moving on from there, basically. So the HTTP request and what it does in the 2017. So yeah, it's pretty good at what it is. It's pretty low on the sizes. I've got my presentation is very minimal. I know that loads of people hate when I do this presentation. It is literally to keep me on track, so don't worry about that. Just revealing everything before I do it. Cool. So, what I've got a Windows XP VM, and I just don't care. It's valid in SmokeBot. SmokeBot accepts Windows 10 to Windows XP. So this is our sample. It is 13.5 kilobytes. It's valid. It's got all of the functionality for its core loading mechanisms and its communication and everything. It is fairly small in bin size. Jeez. So yeah, pretty interesting. Yeah, we're just gonna crack on. There's a few things that I'm gonna say. Yeah, there's a few things I want to say. We are gonna do C2 communication. I just want to say now that I did steal a lot of things. So this person created, I just modified it quite highly. We'll be talking about that in a moment. But also, I did steal from a 2017 leak of SmokeBot the C2 Unpack, simply because it just makes it so much easier. I know what it does. I just don't want to be sitting there for about half an hour trying to work out how to unpack it properly in PHP. Anyway, so if I just restart this and act like I've just loaded this, hopefully I'll give the sample away. It is publicly available on public sandboxes, so you can download this and do it yourself and play along with me. Cool. With that, I absolutely believe that there will be a time where I have to restart and just, yeah, so we'll see how well this goes. Minute 4 and I'm not in there yet. Cool. So at the starting point of SmokeBot, in the 2017 versions, it gets, usually it's packed as well, or there's other things of course with crime, there always is, but with this case, I think I'm at a certain stage where they haven't packed it properly. Anyway, so let's step into it. It's got kind of a crazy sort of starting point here, where we've got loads of jumps at the start, and you wouldn't expect that if you were expecting a CRT, C runtime. So with that, I'm just gonna step over. Now the problem why I'm clicking is because my keyboard is slightly broken. So yeah, that is why. What we're looking for is a particular signature that we very commonly see in malware analysis, which is the process environment block. I don't know why I'm doing this so slowly when I'm showing, I remember why now. I'm showing a different, so there's NOPs here, that's a little bit irregular. Still NOPs. And then we get a call here. This is the big bit. Oh, God. Then we get the call. I'm actually going to increase the font size because I have a sense that it's probably going to be pretty disgusting on YouTube if I don't. So, this is the worst. Ooh, that's a horrible font size. Don't mind me, just do it live. Why not? That's better. That looks better. 14 looks optimal. Or at least for now on my resolution. I apologize, guys, but you know, haters gonna hate. Okay, that's looking good ish. Cool. Okay, everyone can see a little bit better now. Did it again. How I'm going back there is shift asterisk to get back to where my EEIP is, instruction pointer. So we're going to step into this because this looks fairly interesting. We're stepping into what, if I show the main bit, oh, this is not ideal. There we go. It looks fairly, yeah, it looks like program code, so we're just going to do it. Yeah. So we're going in. We see straight away FS EAX, which is strange. Push 30 here and then pop EAX. So that will be FS 30 there. That would be the process environment block. So with that, that's interesting. We've then got two inks here. So if I just step into this and see what's going on. So we've got the process environment block, lovely. Then we got two inks. And then we've got whatever's in EAX, put that into EAX. So if we look, that's +2, so that's process environment starting point +2. So if we go into process hacker, and if we go into the memory and go into the process environment block, it will look different in modern OSs, but there still will be a committed section for 64-bit versions. And another element I'm going to talk about is a little bit different. But if we ink, then we've got here, or we would do, so we're on 0, ink. We've got 1. Process environment block +2 is the is debugged field. So being debugged, so peb +2 being debugged. So with that, we probably ideally want it to be not 1 but 0. The reason for this is they actually use the value that is put here into its jumps so that it makes it a little bit, oh, there we go, much better. And we want to step. Cool. We're going to adjust the register value, and then we're going to go into here, and then you see that EAX is used here to exclusive OR. So if it was debugged, it would be manipulated and changed into something that would go into nonsense, I assume. So we go into there, but that's not just it. So we've got to jump ECX. If we go into there, then we jump into here. So we're jumping all around the place. But this EBX +68 is NT global flag. I'll just come out of presentation for visuals, because why not? So we've got the NT global flag, which will be set in a different place in 64-bit, which I noticed when I had it in two different environments. So in the XP environment, it's going to be 68, but in 64-bit environments, it'll be BC. All you have to look for is P. At least I think so. I think it will always be set to OX70. Could just say 70 in hex. So if we go into the process again, go into the process environment block and go into here. If we look, we've got 60 range there. That looks about 8. That looks about 8. So with that, yeah, we could, there are ways to actually manipulate the global flag, but actually we could just do it in the debugger like everyone else. God, it's horrible when you're recording and debugging. You're so stressed. Cool. And then we do the same thing again. If we get 0, then we will jump to the correct version, because we've been jumping in ECX, if you remember. If we have a manipulated by 71, then it will change the value. When it's 0, it won't change the value. So here we've got the ECX, it won't change the value, if that makes sense. Then eventually we will get to a return. There we go. There we go. So that's us out of the horrible jumping situation that starts in Smoke. So that's to put off analysts when it's being debugged. Then we've got this. So if we go into here, what we're going to want to do is go into this function, as I've breakpointed and called it main. And then we've got some, what I've called API resolve. And the reason why I've called that is because, have I gone past it yet? Oh, we'll see what's pushed in, hopefully. So, and let's go for the call. We've got NTDLL here, and we've got, NTDLL here with a value. We've got also things being pushed in and popped, strange kind of things, but what we want to see is actually probably go in here to investigate. If this was the first time, which we're going to act like it is, we've got some craziness going on in here, but in reality the main thing that probably would trigger me to look at this is this, where we've got this sort of exclusive OR roll, exclusive OR from the higher and lowers in the registers of ECX, and then an increase, and then checking a null byte. So with that, if we go into this and just enter in, one, we can see the manipulation of EBX, EDX, they've got NTDLL coming in, and then they're going into certain positions in EBX, here, and then EDI has got NTDLL, I'm assuming with certain, set positions. So with that, they're going into some weird old places. Then we're loading something. Eventually, it will become more clear what it is. If we step, I'm assuming this is going to be it, where we see the text. Oh, I'm just lying. There we go. Oh, we had to add. Where's he? Oh, we had to add on from. Work out the. Oh, fine, whatever. But at this point, when we were stepping over, now we can see. If you analyze malware a lot, this becomes pretty clear. This is probably some sort of hashing, or it could, what I should rather say is it's indicative of. It doesn't mean it's going to be, but it's indicative. We've seen it before. So yeah. With that, we've got a comparison value with EBP in ECX. If we look upwards, there should be, EAX, EBP there. That is interesting in its own sense, because we've pushed a value, or put a value into EAX, and then it's gone into EBP, and then we're comparing whatever our value here is. Now let's see what happens when we do this. So we're exclusive, well, that's clearing. Then we're putting a byte from EAX, which is the string WCSTOUL. If you're new to this, that's the first API call that will be in NTDLL, or at least when you're trying to iterate through all of them, they seem to go to this. I mean, I could check, but I'm not going to. Cool. So we get an exclusive OR to the higher version of ECX register, which is currently 0, so that will be nothing at the moment. Cool. And then we got a rotation on left 8 times. And then we've got a exclusive OR for the higher end and the lower end. So the rotation really makes this, and then we've got an increase, which will change the, and we'll go to C. So we'll get that it'll iterate through that for a number of times. The main thing probably is watching the result of that, because it will increase, it will iterate to another API call if it's not equal to EBP. So with that, I mean, let's show the end of this. So we've got CST, just watch ECX as well while we're doing this, because you start to see some difference. Well, you see the accumulation of the rotations that make it change so often. If I actually just show this into the dump as well, you can see that's what we're waiting for there. That's why we've got this comparison here on this byte. Increase, we're nearly there. This then indicates, I mean, obviously at the start this was indicative of it being hashing, but just to be really sure everyone gets this, then we've got the ECX EBP comparison, which they don't look saying that. Yeah, no, they don't. I just can't see properly. So we pop that out and then we jump to the next one. So if we go there, it will then go to its next in the array or list or whatever you want to call it, and it will do WCTSOMs. Yes. So what I'm going to do, I've had some problems with breakpoints today. Hopefully this works. There we go. So with the resolution, because it hashed it and then compared it and then found it was correct, it's kept it at that position and knows that it's CW allocate virtual memory, which is good. So then we will get the return there after it's resolved. We see that EX always is the return value, of course, in assembly, even when malware developers are coding. And then we get the return. So with that, the pushes that happened here were used to resolve to ZW allocate virtual memory, and then we see EX being used. If I don't wanna, oh, that's fine. Oh, cool. Cool. So then we've got some allocation of memory, because if I hover, and I've just shown it, we can see ZW allocate virtual memory. That is the only call. And then we've got some, we're gonna skip a little bit of this because otherwise it's gonna take years to go through. This will alloc some memory, and then we'll see it dump into the alloced memory. I'm not gonna walk through how it's deobfuscating, simply because actually quite a few people have actually talked about this already. So let's go and put a breakpoint here. CertPL did a really good job of showing their skills with smoke loader. So there we go. There's going to be a return value. We see the push of 1000 there on the size, I believe. So we go there. There will be after here, there'll be the dump. There we go. Now you might think, oh, that's one character, but then I didn't show it fully, but then we've got all of this down here. Largely because it's got a big font. And then we got some more alloc of memory for other things when it's deobfuscating. And then we've got some dynamic, well, we've got some adjustments here, but we've got this EAX. This is pretty common with stuff like position independent code, and actually some compilers use it as well. They jump through registers, which can be pretty annoying. We can see a resolution there where it's actually adding a position and then EAXing there. So there's adjustments being made to the code to deobfuscate. And what I'm going to do is I'm just going to breakpoint to here. And as you can see from there, we saw the adjustments being made and some things being made into some craziness there. Then we're going to jump EAX here. Now this is where we start to see some homebrew code, because you start to see a lot of NOPs, and these are actually can be seen in the actual sample. So if I get the sample up, and then we just, and this is for a C2, it getting the C2, where it will unXOR it, but there's also alternatives. There's a weird way of getting an alternative C2 out of this thing. So we're just going to put out some bytes. 81, C5, 6, C12, hex values forwards. Is that where we are? Yeah, it is. So we see some more 90s here. We will see some references to somewhere along here. Yeah, 97, 8B, 8B, 8F. So this is HTTP right here. And this will be exclusive words. This sample communicates to what we're about to do. So we'll just go down. If we see, this will be what deobfuscates the C2. So we've got a load of homebrew code of 90s here. What's weird is that some of the code that they've developed, it doesn't have space for the functions, the subroutines, which we'll see. They're very, very tightly, which is why this is 13 kilobytes. Okay, so we're moving out, we're adding to a certain position, and then if we look into ESI, you'll find something that looks very, very familiar. So 97, if you can see that on a very small screen, I understand. 97 8B, so around here. And we got these 90s, so we've just, I believe we started around here, and then we had the big old load of 90s around here, and then we're 8BFO, so we're about here in the code, and the referencing stuff where it's used that add, and then I think it was like BD, yeah, so BD. So if we just let this loop go, it's going to exclusive all into ESI, so it will resolve in the memory. You can see the H, and then that will be put into EDI, yeah. I did not know, no, I didn't notice that. You notice something different every time. There we go. And that will be put there, yep. Cool. And then it checks for the null byte as well. So what I'm going to do is I'm just going to put a breakpoint here, and I'm going to let it play. And then I'm just going to make this a little bit easier to read because it's kind of disgusting. But this is not the C2 we're going to be using today. It's also in the memory here, resolved. So it's moved the ESI result here, and then it jumps back up. Pretty standard stuff. Cool. If we go down a bit, we see also another register being called. What we're going to do is we're just going to skip over a load of this stuff. Oh, boring stuff. Oh. One interesting aspect that we should notice is the push in a moment, where it will push, I think SYN is the word. This will be the campaign ID, and it's available. I say that, there we go. It's available in the unobfuscate, or the actual just straight up bin. So if I search for SYN in here, not a hex value. Oh dear. There we go. So SYN's here. So we could modify and patch the bin and make our own campaign codes. I don't really know why they didn't add that into somewhere else, but cool. So with that, we might see a lot of that in a moment, that whole process, because that's the starting stage, and now we're about to get into the main mechanics of the program, if I'm honest. So before I start with the main part of the program, why have I not renamed that? Zero. Cool. So with that, we've got things that I want to talk about before. We will be looking a bit into anti-analysis checks, but we won't be injecting into Explorer. That I could do in a later video, but I want to talk a bit more about communication as well. But the injection into the Explorer is interesting enough. It's got its own techniques, which has been fairly well documented by other analysts. I just take other people's work, it's clear. But yeah, we'll basically hop in and out of other things, because in this one there's also some threads that I will not run, but will talk about, because they have some interesting stuff in them. But I'll talk about the assembly, I won't actually run it. I'll be setting new origins into places as well. Cool. So hopefully it doesn't break, because this is the function where it always goes wrong for me. So one of the cool things here, we can see FS30. Cool. So we've seen that before, and then we can see it go into EAX. EAX plus C. So what's EAX plus C? Well, luckily, I've got that documented for us. PEB loader data structure. So what does that even mean? That means basically the modules that are loaded in here. So what we'll have here is we've got the modules set here. So these are the current modules that are loaded in. libraries, kernel32 and I believe anti-DLL, or both of them, are run by default with any executable. So with that, all they have to do is basically find them, which you can do in the PEB. So here they're just looking for the modules. So with that, what we're going to do, it will grab a module and push it. So in the first case, it's the actual executable as the first module, which makes sense. It's going to hash that, and I'll just show this for the case. We've seen that before, haven't we? We've seen that before. That hash things, it had some comparisons. It was a little bit more complex before, but these combinations of instructions were in there before. Then we've got the loop. It actually is quite nice and clean for us to be able to look at, which is good. So with that, we expect the result to go into EAX. If I actually just double check, not make myself an idiot. Yeah, it's got the XOR ALAH. Doesn't need to move it anywhere because it's already manipulating it and then incrementing the EDX. Cool. As the counter. Right, we're going to hash the item. That becomes something which we don't want. Technically, we could do some crazy stuff here, and we could call this kernel32.dll and have it hashed there, and then, but that would be if we wanted to do some crazy stuff like watch the functions, create or manipulate the kernel32 and load something else. We could do a load of interesting stuff here, but we don't get that comparison. We don't get that comparison. That's something else, and so we increase and we go somewhere else. So we'll go this again. This time we're pushing something else. What are we pushing? NTDLL. We hash it. This time that is the EAX, so we'll go somewhere else. We'll put that value into EA0. Would you believe it? EA4 will be kernel32. Who knew? So I'll just show that. Kernel32. Lovely. Hash it, please. Yep. Yep. And then we've got EA4. There we go. So we've got the location suddenly. We're done there. We've got the two, and then we move on. Now for resolving API, similar. We're doing the same thing. We're going to push something, and we're going to want it to. We're also, yeah, I should probably explain that. On the arguments section, we can see that one of the arguments is in NTDLL, so we'd expect, if I'm not incorrect, I might be. No, I believe I'm right on this one. Hopefully. It will be a NTDLL binary, API call. So if we go into here, see something very similar that we've seen before, hashing. I could walk through that, but for the space of time, because it's 28 minutes, I'm going to actually just go past that. And we see the adjustment there. RTL get last win 32 error. So we're just going to resolve API again. Get proc address. See that happens there. You can see it dynamically change. And then we've got what I call RC4. Now RC4 is used quite a lot in Smoke Loader, so I'm going to spend a little bit of time talking about this. So we've got, if we go inside it, the reasons why I think it's RC4 is, what is this here? Cool. In this function here, which if you've ever analyzed RC4, you should notice fairly straight away. Only a couple of days ago was I unsure what was RC4 and what was going on, and someone in my team helped me out and showed me it pretty quickly. So what I did is I actually just stepped into here because I was quite interested in this subroutine to start with. Lucky I didn't overstep that. Cool. I went into here. We can see an allocation of memory. We can see EBP -4 being used here, being pushed or moved into EX and then pushed here. So they're just slightly outside of each other, but that value here might be the key, and we'll be able to confirm that in a moment. So with that, let's just bring that up. That looks a little bit better. We've got a little virtual allocation. So we'll look for that return. Cool. It's going to move something into the memory, as we can see. Whoa, boy. And then it's going to be calling this bad boy right here. And we can see the load of arguments being put into here. So follow and dump. That is where we are. Cool. I'm an idiot. We're going to follow this into dump. And this is, if you take very careful attention, 7908 5828. Just endianness has changed them. That will be the correct order for it to be done. So if you want to reproduce this, it would be 7908 5828 to do it. And that's being pushed. And then we've got 4, which I'm going to say now is the length of the key that it uses. I was not sure myself. And then the length of data, which is here. Cool. So with that, we're going to step into it. And the reasons why this is RC4 is, first of all, we've got a setup of incrementing 1, 2, 3, 4 and being put into memory. So that's quite often being done to set up with the key scheduling algorithm, I believe it will be called. So if we just show AL just momentarily. Oh, that's aggravating. There we go. There we go. This will be EAX is currently 0, so that'll be increased, and it will do it for 256. That's hex 100. So, and you can start to see in here, if you look, there's 1, 0, 1, 0, 2. So they're being there, just pushed in. That's quite common for the starting point of RC4. And then toggle. Let's just put that there. We see 1, 2, 3, 4, 5, 6, 7, 8. See a load of that in there. That won't be our key though. If you couldn't identify the key straight away, that's fine. There is a way that I do it as well. So in this point, in this stage, this is what I would call the KSA, key scheduling algorithm. Maybe different. I'm not hot on crypto. The main part of the data and the crypto, or the data and the key, is done here. But we see this comparison to 100 again. So we've got essentially 3 well-known parts, which is this 1, 2, 3, 4, 5, 6, 7, 8 increment into memory. Then we've got this part, which we'll see, which will manipulate the key, which will be constantly modulated. This at this point it's 4, but it can be different until it's got a 256 byte key, which you can use in this round here, which will be done. So it's like a 3-stage process, which is done in assembly. So one of the things that you probably want to identify, have I got rid of the data? No, I haven't. One thing that you can identify is around here there'll be a muta EX. I always identify it. It will be different registers wise, but you can see it. I can instantly see it here. I think you just sort of get used to it, but there is this possibly sometimes you can identify there's like a 3rd argument like the index, but in reality around here it moves the it's swapping the values. In RC4 it has a swap and an exclusive ORs from what I remember. Although saying that there's not a I know there's a swap. I definitely know that there's a swap. Within that they need to grab from here and then also the key. So with that, we've got, hopefully this is going to be, what is the key? This value should be 79. So in what value? EAX. This should be in 79 EAX. There we go. Lovely. So if we follow that into, it'll just be the same area to be fair. Here. So it's just grabbing it from here, and if I just move this along, we'll see some modulation in a moment. So keep watch for this. I'll slow it down so we can see it. So here, and then that'll be 8. I'll fasten it up a little bit now. So the next bit will be 58. There should be a is there? Yeah, there's a div. I can see it. I'm looking for a div. It's up here. Yeah, there's division, which you will expect for any modulation. So we had 58 there, and then the final one before it does the division. Oh God, I've hit a breakpoint, but I didn't want to do that. That's annoying. Maybe I can show that in a bit. I'm not gonna go back. That was libraries. That's aggravating. I hate it when it does that. Is it because it executes still return? Yeah. Dear me. So it was in here, and then encrypt. I could actually just push it, but I'm not gonna. So we've got the div there, and then this will. Is it freed it? Yes. Fuck. Right. Well, next time there's an RC4, I'll show you. But just believe me for now. We've got more resolve APIs that we've seen before. That one's pretty innocuous. It's fine. There we got reg create key, something a bit more interesting. And we got keeps going when HTTP open. That's interesting. Got these, which if we go into them, yeah, that's fine. You start to get used to it. Just to be clear, it's actually resolving something. There you go. And then this one will be, yep. And then it will do the final one, which is shell execute. There you go. And here is where I want to break point, because these are interesting in themselves. They are threads that are used for anti-assembly, or anti-analysis rather. So we've seen create tool help 32 snapshot. Cool. That gets a list of processes. I could do this, but it means I have to restart and it's really boring. Process 32 first. If you've done any sort of programming, you should identify, or C++ programming, you should be able to identify what's going on in this exact place. It's iterating through every single process it can get. So here we can see the process 32 first, it closing the handle, having a little bit of a sleep. We can see that it will get the, where is it? There we go. So we've got the process 32 next. Once it's done that, it will jump into here, get the length, hash the item, and it will do a comparison from EAX to a specified area. These values are likely, there we go. These are likely hash values for analysis tools. I haven't yet. I think maybe in the next episode, if I ever do another one, I could probably brute force my way through to find the hashes for them. But at the moment, I'm not going to do that. But we've got the comparison there. If there's that jump, it will, if you see there, it will jump here into here where it'll open that process and then terminate and close handle. So all it's doing is it's running a thread. If it's got the hash of a 4-byte hash that equals to a process, then it will close it down. And we see that there's 30 values that they've got there, and that's hexadecimal. So that's that thread. And then the next thread is in a similar vein. It's a little bit harder to analyze. Here we've got a enum windows. We've actually got a function that it'll call to check the windows. So with that, let's go into it. You don't necessarily absolutely see that straight away, but it makes sense. We got get class name, string length. What it's checking is the windows, from my knowledge, and it'll look at the class names and it'll use common ones in analysis tools. Similar thing. This time it's got 20. See there. So it adds the 4 because it's a length of 4, and then it will compare another one, and there's 20 in that one. So I don't want them running, funnily enough. So I'm just going to set a new origin here and just move on. Can easily break when you set new origins, so you better watch out for that if you're analysing malware. Cool, so that's the first sort of stage where you sort of have to prepare yourself for analysis tools and remember them. So then we've got the version check, which will be used to understand the integrity, and also that will be saved later to be used in a HTTP request. So what it actually uses is RTL get version. which is a little bit rogue. Most people use get version. I've got slides for this. Very brief ones. So what it's going to do is it's going to check the Windows NT version. XP is 5.1 for anyone. Windows Vista is 6.0, which is the introduction of process integrity, which will help in some form of evading. Well, it will help the malware know if it needs to evade certain security mechanisms that it has. So in a moment, that's what we're about to see. The slides just help me remember what I'm doing. Okay. So again, here we got the comparison of 6. If I go in here and follow and dump, we'll see it's likely 5 or 5.1. Yeah, we got 5, and that's 1. That's the minor. 5 is, I think it's Windows 2000. So then we move and put this into a particular byte. So this will be a flag. If you look at the jump, oh, it's already 0, yeah, that makes sense. And then it will adjust it if it needs to here. Well, it'll make it 1. So if it's below the comparison here, then it will get the integrity level. So it will only jump if it's below, which we are. We're in Windows XP. If it's got the integrity level, it will go into here, get token information. We can see 19 here. So if I just open up my slides again, with that, oh, Jesus. Get token information. What we really want is the token information class, which is the second push, which we just looked at. Token integrity level, which is OX19. Cool. So with that, it makes sense that we see EAX because integrity 200 is medium integrity for a process. So that makes sense for it to bring that return value. Just to make it a little bit more clear, there's the second argument there. That's where it is. Cool. So we don't need to do that. Malware will jump over to here. It won't even protect the process. So we've got some set kernel object security in it, protecting its process so it can't be terminated, but we won't go there. What we will be doing is, just because we've got no security on Windows XP, we'll just be bouncing right off those, and we'll be going straight into a sleep, I believe. Yep. Pretty common for malware to do sleeps. We're just going to manipulate the Z flag there, the 0 flag, and we're just going to get out of there because we don't want to be dealing with that for a moment. Cool. Now that we've done that, what are we doing? We've got some more anti-analysis checks that we're going to go into, and then I'm going to sort of hop over to the C2 beacon for the final bit, because I do know we're hitting 43 minutes here, and people must be really sick of my voice, and maybe we can look a little bit more into that RC4, because I know that was quite annoying. Cool. So with that, I'm going to, what are we moving? We're moving the campaign name actually into memory, into a better location, I think, because we start freeing up memory. There's a lot of freeing up in different stages, and then moving it around. But yeah, the SYN will be used in the HTTP request in the initial stages. So let's have a look at more anti-analysis checks before we start to do any loading. Pretty common for crimeware to be doing this. Cool. Let's have a little again. So we've got the process heap coming here. Okay. We want to get the module file name, the location. So our full location is here. Document settings, link, my documents, samples, smoke, and then this number. Samples is going to be problematic in here, but we're just gonna let it happen. So we got RC4. We might as well go into it. So yeah, you have to burrow a little bit in, but we can see we've got the RC4 there. So what we'll do, we'll just go in. Yeah, let's try this again. Try showing the modulation and go out of it a little bit. But we'll also sort of confirm parts of it as well. I think it's a little bit difficult because it's not as responsive as I was expecting. We can see the key. Can we see the key? Yeah, that's the key. What am I doing? So we've got the allocation of memory, we've got the movement of memory, and then we've got, this will be interesting to decrypt as well, actually. So with that stuff we want to decrypt. Okay. We've got the key somewhere, we've got the value 4, and this time it's a little bit bigger, I think 248, which I can't remember what we did last time, but anyway. So what we're going to do is we're actually just going to breakpoint here and hope that it doesn't break. Yeah, it doesn't. Cool. And then we're just going to do the first bit, which if you remember is here. We're going to see that that is 79. That is the same key that we used beforehand. Not ideal. Okay, let's go around another round. This may be boring for some people at this point, but I just want to really reiterate this point because seeing the modulation is interesting for me anyway. So, oh, I'm not showing the 79. There we go. There's the 79 where we've just been. So we've got the 08. Let's remember to be using this one because I do not want to return out of this. All right. And then we've got the 58. So not sure about myself anymore. 28 is, yeah, 28 is the last one because we've got a 4-byte key. So we'll get to here, 28, and then now this will return sample. Oh, I've done it again. How have I done it again? Oh, I must have a breakpoint somewhere. That's annoying. Execute till return. Oh god. I apologise for this. Really not ideal. Somehow that's right. Well, what's happened here is not ideal. We've actually it's seen samples in a. I knew something would go wrong. I just can't show RC4 anymore. That is RC4. That is so annoying. Oh god. Right. I want the string comparison. How annoying. Just give me a sec and I'll find where we are. Cool. Alright, I'm back. I'm back to where I mean, it's not an ideal analysis environment. So I need to, yeah, start doing that a little bit better. But we saw the result of what could go wrong. Basically, we've got samples in our path here. We used get module file name, and we're going to see the result in a moment. So one of the things I was talking about was that I'm completely obsessed with this now. So we're at 28. So we just need to step a few more times. So we're at 28, and then we're jumping back, and then we'll see the modulation take here, where we see it go back to 79Y. That's what I wanted to show. So that is the key part where it keeps looping using them for if it's given. Essentially, it could have a 1. I'm not. Well, yeah, I think it should. Even if it's 1 byte, it could do it. I think. But this is the main part. It's a stream cipher, not a block. So with that, every byte matters. As in, right, we've got the key set up, which we can modulate around as well at 256. But now each byte from the encrypted data will be encrypted and decrypted by itself as a byte, but in a different way. If that makes sense. If you want to look more, I'm not a cryptography guy, you can definitely have a look on YouTube. There's some great lectures there. We're already on YouTube, so just ignore me and just move on to a different video. Cool, so we've got AL, that will be the first key which we're going to exclusive OR. EDX plus ESI, is that the location we're already at? Let's find out. Following dump. Yes, it is. So we'll see a change here. H, great. And that H will be the debug execute till return. Ooh, had some problems with that, but we'll give it a go. Yeah, we'll slowly see it happen. So we've got Bing. We can see that that is the internet check. It has smoke loaders done, NSTFI or whatever, the Microsoft domain, but they've also done other stuff as well. We've got a few values here which are interesting, but for us, we're actually looking at here, which is sample. There's a few others as well that will be used, but sample is I think anyway, but sample is the one that we check here. So if there's sample in get module file name, then it will it'll want to know about it. So the next bit here, the string length, this is where it's going to try and get sample out of here. So string length test, start doing this. Oh, I don't want to iterate. I just want it to go through it at this point because we're running out of time. Execute till return. There we go. Get sample. Cool. So with that, it does string comparison with the window location, module location. So we see the arguments being set up here. Sample is in it, so it won't have EAX set as I'm assuming it shows the location of where it is. This actually wasn't set as string comparison. I actually checked it. I just identified it from the assembly and also the functionality of it and its comparison at the end. But we can see here we've got the EAX and FFF. This is where we want to actually set the Z flag to say actually we want to go past. If you look, we won't jump. We'll just go into this infinite sleep loop. So it's push 258 on the sleep and then a jump back. So it's an infinite loop. We don't want that for sure. Cool. Then we are going into the hard drive. So we'll do a call for get volume information A. And then we're checking with EBP -4. If I do that, oh no, I'm not doing this correct. EBP -4. Look at that at A4, right? Just remember A4, like A4 paper. A4 9B. So that's the serial number, and then it's checking with other, what I assume is Sandbox serial IDs that they've identified. So we don't need to do that. You see the jumps go back to the sleep on the comparisons. Next on our agenda is Sandbox checking the modules. I believe, is it going to iterate through them? Yeah. Debug help. It wants to check if a number of modules are in the bit here to see if it's been loaded. As well, Sandbox has its own stuff in there. Just checking for more anti-analysis, and then this finally is checking the disk, which a specific value here. We can see it's system control state services disk E number. This is sort of a check for virtual machine. Well, it's not sort of. It is a virtual machine check because of the values that it gets. I didn't show the true. Oh, it's freed it, isn't it? Is it freed it? Yeah, it's freed it. But you saw a load of different of the strings that were being decrypted in the get item. I could walk through that, but I've actually probably done a bit too much RC4 for you guys. Especially, yeah, I need to stop with that. So we've got the query. We're going to put it all to lower so we can understand if it is the same. We're going to get an item which is lower. Kimu is not, so our first one is going to be FFFF. So if we look at what we do, we can see virtual and VMware in here. So this might be interesting. So we got that. That's cool. And then it's going to increase it. We got, I think, 5 checks by the looks of it. Yeah. So the next one is virtual. That won't be. So we need to patch that. to not go. We've got another one as well. VMware, again. Don't want that to happen, unfortunately. An increase, we're not quite there yet. What else have we got? Xen. I think we're fine. Yeah. And then finally, I believe there's one more. Which is that, which I assume is Sandbox stuff, because I do not know what the vibe is there. And then we free some stuff up. Yeah, we free the heap because we're done here. So a lot of Sandbox checks and a lot of analysis checks. Ooh, this is me mucking about. I want to return here. Yep. Is this going to work? No. Brill. Okay, give me a sec. I'm just going to fix this up. Cool, I'm back. I'm just getting trying to be too clever with a set new origin sometimes when it goes wrong, unfortunately. Also having problems with breakpoints in here. I think it's a different way and compared to Windows 10. I'm so used to the Windows 10 VMs. Cool. So we did the anti-analysis checks where we had some interesting times. Now we're going to probably look more into the C2 beacon. Executive above Vista and injection into Explorer. I can look at more if people are interested, but nowadays now I'm gonna go into here. I'm gonna ignore this part largely because this is related to the functionality that we've just talked about, and I'm gonna be going in here. Now this is related to something we're also going to be skipping, which is the moving into random locations, creating. It uses get tick count and uses RTL random and seeding, and then generates characters through that to change the location and its file name. So we're going to start here, but we're not going to go into that functionality, which will give us get tick count. We can see that. If you didn't see the hover, there you go. There it is. Very clear, very simple. What we're going to do is we're going to go into here. We're going to go through this. We can see a get item. That's interesting. We want to go into a certain registry key, Microsoft Internet Explorer. So cool, reg open, pretty standard. What do we want? What key? We want something called SVC version. And what, by the looks of it, this is going to be related to this is going to help us obtain a user agent string. So what else are we're going to do? Query the version 8. It's 11 in my Windows VM, so interesting. And we're going to create that as a number, and we can see 008 reg close key, and we can see the push to EAX here, and then obtain user agent string, and then it'll become more apparent in a second. In the push, we see it there. So we've got our user agent. They've got that from registry. Yeah, that's fine. Looking at that, oh god, where are we going? That's fine. Formatting that, and then we've got a. Ooh. Oh yeah, this is the. I've just remembered what I was getting worried then. This will be the Bing check, yeah, which we saw at the start, that string at the start that I got. So we should see Bing, yeah. Can we show you the full dump? Oh no, it's just copied that. Okay, well we saw it previously anyway. So if we go into this function, there's some pretty simple stuff which I'm going to go into. For starters, it opens it up. Puts the URL in there, connects. There's some RC4 encryption it will skip in this case, but is really interesting in a moment. It'll open a request, set the option. I believe it'll set the option. You know what? We've got, well, it's 59, but we'll go in it. It makes sense. So we've got Bing set in EAX. We're just going to go over these because these, while important when you're looking over a sample at the moment, because of time, I'm trying to clear up. So we've got Bing going in, memory, Seeing it jumping around the place. What the hell was that? Oh. Just getting worried then, that was quite a lot of execution. So, proxy config, yeah, making sure that we've got the right so we can connect out. Then we've got WinH2U open to open up the handle, which we could look at Process Hacker, but in the event of time, I'm not going to. More preparation for the HTTP requests. Crack URL. We are going to skip that. We're going to connect to bing.com. Now, the difference here is that I don't have the internet connected here on the VM. What I've done is I've done a classic trick, which I think a load of people have done in their times when they've been playing games, I'm sure, is we're going into System 32 and we are going into drivers. And we are going into etc hosts, if I can read words. There we go, hosts, and if I edit that in Notepad, we see Bing is set to 127.0.0.1. I've got a web server being called. I've also got the C2, which is set there. A little bit of surprise there for you guys. It's actually just going to connect to a local web server. That's why I'm showing that. Cool. We're going to skip the encryption. We're going to go straight into opening up the request and then sending a request. So we've got open request, reading the data as well. That is pretty integral. So apparently we don't set an option. I lied. We got send request. Testing it, 01, successful. That can be tricky sometimes if you've got TLS. Learned that one the hard way. Receive response, lovely. We'll receive a response. What do we expect as our response? We expect a load of A's. Okay. Success. We're going to allocate some heaps. We can read. We can all read. This is where I'm just talking about API calls. And then we're going to read the data in to have a look at what's being put here. So we can see the A's here. Cool. Lovely. And the cool thing about this is that the check here is actually pretty ridiculous. It doesn't check for any of the characters, which we will see in a moment. What it will do is it will check on length. And it's not a big length either. It's only checking a certain amount of length. Okay, we've not got that long. So, got A's there. You can see them still in the registers being moved around. Got some freeze from the temporary data. Close of the handles. And then A's are back. Of course they are. And then we're checking on the length. So here we've got if you look, we've got the length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I believe that's correct. 0C should be 12. Well, I've miscounted the A's in the register, but that is the length of the request. Cool, so we're comparing that. It is above, greater, or equal than, so we go further. Otherwise, we'd sleep and we'd just loop. So you can see a push AX. We're freeing some memory, which is probably the response it is. EAX the registers. Then we've got a sleep, and then we've got to jump up to here, which will just loop up. Cool. So we don't do that though, because it is greater than. We're going to go over, and we're going to free the response anyway. Push EAX, free the response. And then we're going to get info, which is the integral part, because what that is, I'm going to get bot ID. There's probably more in there, but the main thing is the bot ID, which we saw right at the start. Right at the start of this whole thing. These big long IDs, what the hell are they? The IPs here and the dates are all done by the request, what it's actually doing. It doesn't have like an internal or external IP check. Operating system is done. Privileges, as you can see, low, medium is done. Sellers is the what I call campaign ID. So you got that. Cool. Back into here. Let's go in and let's check it out. So we get computer name. I think this might fail. Or it won't, who knows. But we'll get a computer name. We get an error, but actually there was, if you look, there was actually, it did work. Like there was a value that it put it in. Has it moved it? And I can't see it. There we go. So this is the value. Just to be... There you go. Hang on, that's not showing it. That's not showing it at all. Where is it? It's in token, isn't it? Yeah. So there you go. There's the domain. So it has worked. And then what we're going to see is get volume information A being used as well, which we've seen previously. It's been A4. And that will be put into a certain bit of memory. We've got some allocation of some heaps. We've got a decryption. We've got the reference to our computer. And we'll get that. Yep. So that'll be put into... You can see the concatenation there because we've got the A4 there. We can see that. And then crypt acquire context, which is interesting. What I'm doing is I'm just going to exit out. Yep, we talked about the token information. So bot ID generation, the host name or the domain or the computer name, whatever you want to call it, the hard drive serial number. And what we're doing is we'll be going crypt create hash, and we'll be trying to look for alg ID, the second parameter in the function, and or argument in the function, and what we're going to be looking for is the 0x003, which will be the MD5 argument, or constant rather. So with that, let's go in and start hashing things. We're pushing stuff. Yes, we are. There we go. We can see it in the arguments, and we're just going to go in here. Oh wow, we can see crypt create hash. Who knew? You can already see it already, but acquire context, yep. We want to just keep going. We see the 8003 there. Cool. See the crypt create hash data there. And then we will start to make sense of it in a moment here. It has gone into a certain area of memory. Oh mate, I should have got a keyboard. Should have got a keyboard. There we go. So 40 will be the start of the hash. Yeah. So you know what? Just to make sense of it all, I am going to get I'm going to copy this. I'm going to go into CyberChef and show you it MD5 to confirm. Okay, cool. Let's put this into here. Not create a new line. That would destroy my whole idea. 40FD1D. Cool. So if we go back, yep. And then go into here. Oh God. There we go. Back we go. We got 40, and then we should expect. Let's just show. Yep. Following done. Yep. We should be expecting a 40 maybe. Just to verify we are correct. FD. That is correct. I'm just going to double check. It's been a long day. FD. Yeah, cool. So we got that right. Cool. So we know that. But that isn't the end of the bot ID. No siree. With that, allocate virtual. Oh god, see, this is where it can get confusing because you see these returns, they're so tightly packed. return's actually there. Debug execute till return. See the building up of the hash there? Lovely. And then what else do we want? What are we getting here? Yeah, we sometimes with padding add FF, but we don't need to. Which actually looks like it might be done in a second, but that's the hard drive serial number, and that will be concatenated, as we can see already in there. We can see it there. So that is the, well, that's the bot ID gen. Cool, so that is our bot ID. So we've got the MD5, and then afterwards, so we got 32, which is the length of MD5, and then after that, the actual content is the hard drive serial number without the dashes in. Cool. And then we're just going to make sure everything is fine. This is where the FF can be appended, I believe. Has that been appended? Not sure. No, I think it's fine. Because it needs to be a certain size, I believe. And then it creates the mutex, which means that it needs to currently run for it to then be doing something else. But what we're going to do is, like I've said before, we're going to avoid the move to random folders and create stuff. And we're actually going to, first it's going to resolve the C2, which we won't go into because we're hour and 11. And then what we're going to do is we're just now going to go into send initial request. It's been a long old one. Hopefully it's fun. So yeah, we're going to go into here. We're just going to let it resolve the C2. We see it there, Dogeware service. We've already got that in the hosts file, so no worries about that. We're just going to go in now and look at all of the cool stuff it's going to do. So what is that? That is a, it's beginning to now create the packet. So we're going to get some concatenation going on in a second. Is that the location we're at? No. We can see 71 here. This is the starting point for the task ID. What am I doing? Where am I? There we go. Cool. So it's going to be pushing that. Concatenating that. Which one is this? This is, oh, we have no idea. I think that's a campaign ID, which is supposed to be SYN, but I think we've lost it in the way. Cool, and I mean, we don't need to watch this. It's getting the version, so we've seen this before. And let's put it into AL. It was being shifted, then moved, added there, then being put into ESI plus 31. Is that ESI plus 31? Oh, word. Apparently it is. Cool. It is because, oh god. We want to be upwards a little bit. There we go. So here's the task. So 01 E1 will be the start, or E1 1707 here. These 2 bytes here, the start. Then we've got the bot ID, which is fairly long. Then we have got that should be the campaign ID. I'm not sure why it's not in there right now. And then we could actually just put in something else that we want. Could we do that? Let's just put in something. Yeah, let's call it 11. This is the version number. It's still creating the packet, so we'll see the task ID in a moment change on this row. There'll be an adjustment. There we go, 1127. That is the task ID, and then some more flags. Cool. Lovely. And then we are going to be putting this in a HTTP request. and this is we're nearing the end, guys. We're nearing the end of what we're going to be looking at today. So with that, we've been here before with Bing.com. So Dojeware service, we're going to 191C29 is not really that interesting for us, I believe. What we want to see is that it actually uses a different RC4 key for string decryption and receiving and sending. So there's at least 3 RC4 keys being used, all in different ways. So we've got WinHDB open, that's positive. You always get worried with Windows when it comes down with the Win HTTP reliability. It's always a bit strange. Right, we are jumping, we're connecting, but then we're going to successfully connect, but then we're going to be encrypting our stuff because we're going to be wanting to not have it plain text. What is that? Not sure. It's string decryption. Cool. Probably RC4, but no, not time. What we can see, it doesn't jump here. We see this is the key, and this is a lot more brunt. This is, yep, there's RC4, and we've seen this before, and it's pretty evident. We see the 3 stages, and this is going to be encrypting this. So in that, what I've set up the. I can't say that some of this code isn't stolen. So of course this is from the panel. This is from the panel, slightly adjusted. The RC4 is actually from GitHub, and this is just me dicking about. So essentially what we're going to be doing here is we're going to be accepting anything that comes into this, any request that comes in to index.php, we're going to be putting it into a file but get contents, which probably has already got something in because we did that bing.com, but it should be for empty or nothing. Yeah, it's got nothing in. And what it's going to be doing is just to put that into dump request.txt. We're going to read that, and we're going to get it. We're going to unpack it with the key C4, which we've got from the sample. Each sample, of course, or each C2 has its own keys for communication at change. That's why they have a define in their panel. That isn't just to make nothing, make it useless. And then I'm just adding it to a table to make it look a little bit better for us to look at once we've unpacked it. So we should be able to look at that in a moment. And that will essentially, we've just looked at the communication and understood it. Of course, we can go further. We can look into the next few steps. Maybe that's something you guys are interested in. Maybe comment that for me. But yeah, for now, that's what we're going to be looking at. This should be RC4 encrypted. There we go. And then we're going to be opening up the request and sending it. We're sending it. I guess you could validate the headers. The thing is that the actual bots panel checks the first 2 bytes, which is actually the year that it's generated. So in this one, it's 2017. But there's 2018. I'm assuming they've got it the same as Magic in the 2020s builds. But yeah, their builds always respond. Their Magic number at the start always corresponds to the year. We don't need to add any headers. We're going to send the request and then we're going to verify. We don't need to worry about the response. All we care about is send request and it being 1. It is. Cool. And then we're going to look at the dump request. We've got some RC4 data. That is the correct amount, 3F. With that, the final thing I can show you today is the confirmation that it works, and it has. So we've got the Magic 2017, we've got the ID, we've got the campaign, we've got the OS and its admin and the command ID. Hopefully that you guys enjoyed that. 1 hour or 20 minutes of randomness and getting through the sample and bits of it. If you want to see more of this, I can just look through the sample completely, modify it, make our own panel from it, make changes to it, completely modify it. But from the starting point of us looking at it and understanding its initial functionality from the point of anti-analysis to the point that it's sending its initial request with a little bit of mucking around in. Hopefully you guys enjoyed that, and I'll see you in the next video. Please comment on whether you liked it or not.